Well, last time we discussed about particle in one-dimensional box. Okay, that means application of Schrödinger equation. Okay, so we considered a system, and that is particle in one-dimensional box. Then we wrote the Schrödinger equation and we solved it. Okay, we solved it. And by solving the Schrödinger equation, we obtained two things. One is energy, okay, energy, and the other is the wave function, wave function, okay. So these are the two things we obtained: energy and wave function. Then we discussed about the significance of the energy expression, okay. So we also discussed about the significance of the wave function, okay, significance of the wave function. And in order to discuss about the significance of the wave function, we have to plot psi, we have to plot psi versus x, okay. But plot of psi square is more important than plot of psi. So because psi square gives the probability of finding the particle. Okay, so we have already discussed about this. Now let us solve some problems. Okay, let us solve some problems related to particle in one-dimensional box. Okay, say number one question say find the wavelength find the wavelength of the radiation emitted when a particle of mass 1.5 into 10 to the power minus 24 gram gram in a one-dimensional box of length 2 angstrom undergoes transition from n equal to 2 to n equal to 1 level. Okay, so this is the question. So what has been given? You see what has been given. Mass of the particle is given. Mass of the particle is 1.5 into 10 to the power minus 24 gram. I can write it 27 kg. Let me write in SI. Okay. So 27 kg. And one-dimensional box. And length of the box is 2 angstrom. Okay. That means length of the box means A, 2 angstrom. 2 angstrom means 2 into 10 to the power minus 10 meter. Okay, 10 meter. Then it undergoes transition from n equal to 2 level to n equal to 1 level. Okay, now how much energy is emitted? So this is a n equal to 1 level. Here energy is E1. This is the n equal to 2 level. Here energy to E2. So how much energy is emitted? So it undergoes transition from E2 to E1. So how much energy is emitted? Energy emitted. Okay, energy emitted from higher energy to lower energy, transition from higher energy to lower energy. So energy is emitted, that is equal to del E, which is equal to E2 minus E1. Okay, and we know what is the energy expression. Energy expression is this: n square h square by 8 ma square. Okay, that means 4 h square by 8 ma square. Okay, 2 n square h square, n square h square, n equal to 2, this n equal to 1, so h square by 8 m a square. Okay, this is equal to 3 h square by 8 m a square. So this much energy is emitted, and this much energy is emitted in the form of radiation. This much energy is emitted in the form of radiation. So what is the energy of radiation? Energy of radiation is h nu. Okay, since energy can neither be created nor destroyed, so energy of radiation emitted, so energy of radiation emitted h nu must be equal to del E, that is equal to 3 h square by 8 m a square. So h cancels, so nu, what has been asked? Wavelength. So nu equal to c by lambda, that is equal to 3h 8 m a square a square. Hence lambda will be equal to 8 m a square c by 3h, and that is equal to 8. What is the mass? 1.5 into 10 to the power minus 27 kg. A square equal to 2 into 10 to the power minus 10 meter square. C equal to 3 into 10 to the power 8 meter per second, and 3 into 6.6 into 10 to the power minus 34 joule second. So you just simplify. Okay, and what will be the unit? So kg meter square meter per second, kg meter square meter per second. Joule means Newton into meter. Okay, joule means Newton into meter second. Okay, Newton equal to kg meter per second square, so kg cancels. Okay, meter square cancels, second cancel, so unit is meter. Okay, unit is meter. So you have to solve this and find out the value. Okay, so simple problem, no difficulty at all. Next, let us see another problem. For a particle in one-dimensional box, show that the average value of momentum along x-axis is 0. Okay, average value of momentum along x-axis is 0. We have to prove this. Okay, so in the postulates of quantum mechanics, we have seen average value of a physical quantity. Average value of a physical quantity equal to psi operator for the physical quantity psi d tau psi d tau. Okay, when psi is real. In general, we may write like this, that is complex conjugate. If psi is real, psi star complex conjugate psi star will be equal to psi if psi is real. But if psi is complex, then it will be different, minus. Okay, so for real value of psi, we may just write psi m psi d tau this. Okay, because for real quantity psi star equal to psi. So average value of a physical quantity, this is the physical quantity and this is the operator for the physical quantity. Okay, so we have seen this from the postulates of quantum mechanics. Now here we have been asked particle in one-dimensional box. So what is psi? We know 2 by a whole to the power half sine n pi x by a. We know this. That is real. And momentum. Okay. So let me write. So average value of momentum in x dimension. Momentum in x dimension. Average value. This means average value. Okay. Now here, this is psi. Okay, psi, and m, operator for momentum. What is the operator for momentum? H bar by I d dx. Okay, then psi dx. And what is the limit? 0 to a. So it will be 0 to a psi dx. So it will be this. Okay. So we can take h bar by I common. And what is psi? Now you see, we know the wave function for particle in one-dimensional box is normalized. Okay? Wave function for particle in one-dimensional box is normalized. So integration psi dx 0 to a, that will be equal to 1 because that is psi squared, because wave function for particle in one-dimensional box is normalized. Normalized means this integration is equal to 1. So we can just write, let me write here, we can write 0 to a psi. What is psi? 2 by a whole to the power half sine n pi x by n pi h by h bar by I d dx. Okay, then 2 by a sine n pi x by a. Okay, n pi x by a dx. Okay, so this is the expression. Then we can write it like this. average value of momentum, we can write it like this. So h bar by I common, h bar by I common, then 2 by a whole to the power half into whole to the power half. So we can take it out. Then integration 0 to a sin n pi x by a d dx of sin n pi x by a dx. So we get this. Okay, now h bar by I 2 by a. Now d dx of this, okay, d dx of this, that is equal to n pi x by a d dx of this equal to cos, okay, cos of this into constant, okay. So this is equal to 0 to a sin n pi x by a, okay. So this will be cos n pi x by a dx, okay. So now sine of 2a equal to 2 sin a cos a. So we can apply this. Here. Sine of 2a, sin a cos a. So I can write it like this: h bar by I n pi x by a, okay, n pi x by a 0 to a 2 2 sin a cos a. So it will be sin 2 n pi x by a dx. So we can write it like this, okay. 2 here, okay, 2 sin a cos a. So I can write sin 2a equal to this. Now integration of this equal to minus, okay, this equal to h bar by I, this is minus, integration of this equal to minus n pi x by a into 1 by a by 2 n pi x cos 2 n pi x by a 0 a, okay. So this will be equal to minus h bar by I n pi x by a, sorry, not, this is not x, sorry, not x, sorry, x is not there, x is variable, sorry, 2 n pi, okay. Now this is a by 2 n pi, now this is cos 0, cos a cancel 2 n pi, cos 2 n pi equal to 1, cos 2 pi equal to 1, cos 4 pi equal to 1, minus cos 0 1, that means 0, that is equal to 0. So our average value of momentum is 0, okay. So we have proved it. A similar example, so you try at home, okay, and if you find any difficulty you can ask me, okay. So question, I leave it to you. Question: using the particle particle in 1D box wave function calculate the average value of px square. Calculate the average value of px square. Okay, so we have to find out the average value of px square. Now similar problem. So here we wrote h. Okay, px equal to h bar by I d dx. In case of px square, we have to put here this square. Okay, we have to put here this square. Then we have to solve it. So you try to do this. Okay, I leave it to you. So I leave it to you. Next, another problem. Let us see. Let me find out another problem. Okay. Treating the pi electrons in a conjugated system has particles in 1D box. Calculate the lowest absorption frequency and the corresponding wavelength of the absorbed radiation for butadiene. Okay, for butadiene. The length of the molecule is 0.56 nanometer. Okay, 0.56 nanometer. So you see what has been asked. Okay, so this is the butadiene system. So this is butadiene system. I am not putting the double bonds. Okay, this is the butadiene system. So length of the molecule is taken to be 0.56 nanometer. So pi electrons are there, and pi electrons are to be considered as particles in one-dimensional box. So how many pi electrons are there? There are 4 pi electrons. So these 4 pi electrons are to be considered as particles in one-dimensional box. Okay, particles in one-dimensional box. Then what we have to calculate? We have to calculate the frequency of the radiation absorbed and the corresponding wavelength. Okay, so the problem is Similar type of problem we have already solved. Though here the problems seems to be very difficult, actually it is not like that. Not so difficult. Okay? It appears that the problem is very difficult, but it is not so actually. Because this type of problem we have already solved. Okay? So here you see, so in this problem what we calculated, we calculated the energy difference. We use the particle in one-dimensional box energy expression, and um, we calculated the energy difference between the two levels. Okay. Now here also what we do, we use the same energy expression, particle in one-dimensional box. So energy expression is this. So energy expression is this: n square h square by 8 m a square. Okay, energy expression is this. N equal to 1, so n equal to 1, then energy U1 equal to h square by 8 m a square. Okay, n equal to 2, energy 4h square by 8 m a square, energy 3, n equal to 3, so energy equal to 9h square 8 m a square. Now here you see the conditions. So 4 electrons are there. This is the lowest energy level. Okay, this is the lowest energy level. N equal to 1, energy E1. This is the next energy level, n equal to 2, and energy E2. This is the third energy level, E3. Okay, so we know these are the pi MOs now. These are the pi MOs. Okay, because we are considering pi electrons, so these are the pi MOs. This is one pi MO, another pi MO, another pi MO. Okay, now in one orbital, in one MO molecular orbital, you can put a maximum of 2 electrons. So 2 electrons are there, 2 electrons are there. So this is the condition. Okay. Now what has been asked? You have to calculate the lowest absorption frequency. Lowest frequency means lowest energy, because energy is proportional to frequency. So we have to calculate lowest absorption frequency. That means we have to calculate lowest energy. And absorption means the electron will move from lower energy level to the upper energy level, because only then energy will be absorbed. Okay, and where from the electron will move? From highest occupied molecular orbital, highest occupied molecular orbital, highest occupied molecular orbital to lowest unoccupied molecular orbital. Lowest unoccupied molecular orbital, electron will move. Okay, so when the electron moves from lower energy level to higher energy level, energy is absorbed. Okay, conversely, higher energy level to lower energy level, energy is released. Okay, here energy is absorbed. So this is the transition. So how much energy is absorbed? How much energy absorbed? Del E equal to energy absorbed. Energy absorbed. Del E, E3 minus E2, and that will be equal to 5h square by 8m a square. 9 minus 4, 5. Okay, energy absorbed. So the energy of radiation absorbed, energy of radiation absorbed, h nu must be equal to this 5 h square by 8 m square. Okay, then nu, we will get nu equal to 5 h by 8 m square. Okay, so you know h. Okay, you know m. Here m is the mass of the electron, so just put the values and you will get the answer. 5, 6.6, 10 to the power minus 34 joule second, 8, 9.1 into 10 to the power minus 31 kg, and 0.56 into 10 to the power minus 9 meter square. So you just simplify and you will get the answer. So this will be per second, unit will be per second. Okay, you will get the answer. Then you calculate lambda equal to c by nu. So you calculate this. So not difficult. Okay, you can do it. Then let me see another problem if I can find out. Let me see another problem. Okay. Another problem, let us see. Another problem, let us see. Show that any two wave functions of particle in 1D box are orthogonal. Okay, so what does it mean? Say one wave function, any two wave functions of particle in one dimensional box. So one wave function, say let me call it psi 1, and that is equal to 2 by a whole to the power half sine pi x by a. Okay, and say psi 2 by a whole to the power half sine 2 pi x by a. Okay, or in general, if we write in general, so this is say m and this is say n, then it will be m pi x, this will be n pi x, like that. In place of 1, 2, I can write mn. Okay, so these are the two wave functions for particle in one dimensional box. And what we are to prove? We are to prove that these two wave functions are orthogonal. Orthogonal means integration. To prove, we are to prove that integration 0 to a psi m psi n dx equal to 0. We have to prove this. we have to prove this. Okay, so how to do this? Say left hand side. Okay, left hand side equal to, so 0 to a, 0 to a, say sine, let me write it like this, sine n pi x by a and sine m pi x by a dx. Okay, dx. Then we have the constant 2 by a, 2 by a into 2 by a, so we can write it like this, 2 by a constant, half half, we can write it like this. Okay, so that is equal to 1 by a, 0 to a, so I can write it, um, I can write it like this, that is equal to 2, 2, and let me, okay, I can write it like this. Okay, uh, 2 sine n pi x by a sine m pi x by a dx. Okay, 2 sine a sine b. Okay, 2 sine a sine b, sine b. So this thing I can write it like this. Okay, I can write it like this. So integration 1 by a, that's of course there, uh, 0 to a. So you see, say cos of cos of n pi x, cos of n pi x minus cos of n pi x by a, minus m pi x by a, n minus m pi x by a, cos of this equal to 2 sin a cos a, then okay, then we can write it like this, we can write it like this, cos of n minus m pi x by a, pi x by a minus cos of n plus m pi x by a, pi x by a, x by a dx. It will be like this. Okay, it will be like this, one half will be there. So this is equal to 1 by 2a, then there will be two integrations. One integration is 0 to a cos n minus m pi x by a minus 0 to a n plus m cos pi x by a dx. Sorry, this is dx. Okay, cos dx. then this will be equal to 1 by 2a, and this integration will be equal to sine of okay, before that this constant a by n minus m pi, then sine n minus m pi x by a 0 a okay, minus this is a by n plus m pi sine n plus m pi x by a 0 a. Okay, so we are getting these results. So 1 by 2a a n minus m pi then this is a equal to this, so pi sine this will be sine pi means 0. Okay, this is sine pi, so 0, and this will be 0 0. Okay, similarly this will be 0, this will be 0 0. Okay, so 0 0, ultimately this will be 0. So these two wave functions are orthogonal. So in this way we can solve some problems. Okay, now let us consider another system, which is particle in 3D box. Another system let us consider. So here system is that, so we consider a box. Okay, we consider a box like this, okay, consider a box like this. Say this is the x-axis, this is the y-axis, and this is z-axis. So a particle of mass m is moving inside the box. Okay, particle of mass m is moving inside the box, inside the 3D box of lengths A, B, and C along x, y, and z axis respectively. Okay, so length of the box along x-axis is A, length of the box along y-axis is B, length of the box along z-axis is C. So these are the dimensions of the box. X, along x, A, along y, B, along z, C. These are the dimensions of the box. And a particle is moving inside the box. We further assume that potential within the box is 0 and outside the box is infinity. We further assume So the particle is here within the box, and within the box potential is zero, just like in particle in one-dimensional box. Inside the box potential is zero, outside the box infinity. Okay, that means outside the box psi is zero, outside the box psi is zero, inside the box psi is not zero, not zero. Okay, so this is the system we have considered. Now for the system, time independent Schrödinger equation. For time independent Schrödinger equation is minus h bar square by 2m del 2 psi. Now partial differentiation, del x square del 2 psi del y square del 2 psi del z square plus v psi equal to e psi. So this is equation number 1. Okay, Schrödinger equation in 3 dimension. This is the equation. Now here v is equal to 0. So since v equal to 0, so we have the equation like this. Del z square equal to e psi, since p equal to 0 here. Okay, now in this equation here what happens, here this psi is actually a function of x, y, z. There are 3 variables. Okay, there are 3 variables. This psi is a function of x, y, z. There are 3 variables. Now in order to solve the Schrödinger equation containing more than one variable, in order to solve the Schrödinger equation containing more than one variable, what we do? Okay, Schrödinger equation যদি এটাতকে বেছি ভেৰিয়েবল থাকে তেনেহলে আমি Schrödinger equation to কেনেকে solve কৰো? Okay, how we solve the Schrödinger equation? So how we solve? First we divide the equation into as many daughter equations as the number of variables. Equation to jimanta variable thakibo himanta equation loi parent equation to ami divide korim. We will divide the parent equation into as many equations as the number of variables. So there are 3 variables. So we will divide the equation into 3 daughter equations. Okay, so first we will divide this equation into 3 daughter equations because there are 3 variables. Okay, now how to divide this equation into 3 daughter equations? Okay, ইয়াক আমি কেনেকে 3টা ইকুৱেশ্যনত ডিভাইড কৰিম না? For that we assume let this psi be a function of 3 independent functions. Okay, so here this x, in place of this I may write this f1 also. I may write f1. This is simple only. Function. F1 means function. We may write like this. In place of this we may write say f2. That means capital X is a function function of x. Capital Y is a function of y. So in place of capital X or capital Y or capital Z, we may write F1, F2, F3. Because these are symbols only. These are symbols only. They represent function. Okay, function. So for convenience, we are writing x. So here x or xx or xx. This is a function of x and independent of y and z. So this is a function of x only. That means this function, value of this depends on x only. But value of this is independent of y and z. Similarly, y or yy is a function of capital Y or yy is a function of y and independent of x, z. Similarly, this is a function of z and independent of x, y. So that is important. You have to write that. You have to write that. Okay. So y is a function of y independent of x and z. Similarly, y or this, z or z is a function of z independent of x and y. So this is important. You have to write. That means what we are doing, we are expressing this function. We are expressing this function as a product of three independent functions. We are expressing this function as a product of three independent functions. So this is the first step. How to divide this equation into three equations? This is the first step. We assume this. Then in this equation, we have this. So from this, okay, let this be 3. So from this, we will find out the value of this, we will find out the value of this, we will find out the value of this. Okay? So what we do? So del 2 psi del x square. That means we are differentiating with respect to x. Then this will be double differentiation x. We are differentiating with respect to x. So y and z, they are constant. Because this is independent of y, z. We are differentiating with respect to x. Okay, so they are constant. Similarly, del 2 psi del y square, that will be equal to y double dash y x z, and similarly del 2 psi del z square. Okay. Now we replace these values. We replace these values in equation 2. We replace these values in equation 2. So from 2, what do we get? So from 2, what do we get? Minus h bar square by 2m x double dash x x y y z z plus y double dash y x x z z plus z double dash z x x y y. So this okay, then that is equal to e psi. Psi means x x y y z z, because psi means this. We have taken this psi equal to this. Okay, we have taken this psi equal to this. So for this we are writing x double dash x y y z z, similarly this and this. Okay, so we are getting this. Now we divide both sides. We divide both sides by this. Dividing both sides by this. Dividing both sides by this, or we get minus h bar square by 2m. So what we get? This will be x double dash x by xx, because this will cancel. We are dividing by this, so they will be cancel. Similarly, y double dash y y y z double dash z z z, okay, and this will be equal to e. So this is the equation number, how much? Equation number 4. This is equation number 4. Okay, so we have got this equation number 4. Now equation 4 can be written like this. Equation 4 can be written like this: minus h bar square by 2m x double dash x x x, that is equal to e plus h bar square by 2m, okay, into y y y y z z z. We can write like this. Okay, now here you see we are differentiating x double dash x means we are differentiating with respect to x, and when we differentiate with respect to the x, this will be constant. This will be constant because this is constant, this is constant, because there is no x, there are y and z. So we are differentiating with respect to x double dash x, so this will be constant. Okay, this will be constant. So let me write it as you can say like this also: left hand side depends on x, left hand side depends on x, but right hand side is independent of x. It depends on, right hand side depends on y and z only. Okay, similarly the right hand side depends on y and z, left hand side independent. So we can say that this is equal to, so we can say that this is equal to some constant. Let me write it as ex. This is constant. Okay, because we are differentiating with respect to x, so definitely this will be constant. Okay, so we can write it as this, or we can write it like this: minus h bar square by 2m x double dash x f double dash x. What does it mean? d2 fx by dx square. It means this. Similarly, x double dash x, it means d2 xx by dx square. So this is equal to this, and this is equal to ex xx. Okay, and what is xx? What is xx? This is a function of x. This is a function of x. This is simple only. Okay, we have already said that in place of xx we may write fx, we may write psi x, we may write psi x. Okay, so if we, that is equal to psi, because this is equal to x. Okay, so in place of xx we may write fx, or we may write just f function, or in place of xx we may write psi x, or simply psi. So if we write just psi, it will be, let me show you. If we just write psi, then this will be 2m d2 psi by dx square equal to ex psi, okay. If we write psi, in place of xx, so it is this. Now what is this? Here psi is a function of x, xx is a function of x, same thing. Okay, so what does this equation represent? This equation represents particle in one-dimensional box. This equation represents particle in one-dimensional box. This is the equation 5. This is the equation 5. So equation 5 represents a particle in 1D box confined between two potential walls, one at x equal to 0 and the other at x equal to a. So particle in one dimensional box only. Now you see this is x, okay, this is x, this is the wall, inside these two walls potential energy is 0, inside these two walls potential energy is 0. Okay, particle is moving here, and here x equal to 0, here x equal to a, so length of the box is a. So this equation represents particle in one-dimensional box only. This equation represents particle in one-dimensional box only. So we can use these results. We need not have to solve, because we have already solved the equation for particle in one-dimensional box. So we need not have to solve once again. So from 5 what we get? Xx or psi, xx or psi, that is equal to 2 by a whole to the power half sine n pi x, that means nx pi x by a. Okay, and energy, okay, energy equal to nx square h square by 8m a square. Okay, where nx equal to 1, 2, 3, etc. Okay, similarly from 4 we can write Okay, let me show you. So from 4 we can write this. From 4 we can write this. Say minus h bar square by 2m y double dash y equal to e plus um, 2 h bar square by 2m h bar square by 2m x double dash x z double dash z. So we can write like this. Again we are differentiating with respect to y, so this is constant. So again we can write it as ey constant. Okay, we can write it constant. So again we can write it like this. As before we can write it like this. So again this equation represents particle in one-dimensional box along y. So you see along y. So you see now particle in one-dimensional box along y. So it is confined between two walls, one wall, the other wall, where potential energy is 0. Okay, so y-axis, these are the two walls. Length of the box is b. Y equal to 0, y equal to b. Length of the box is b. Okay, and potential here is 0. So again that will represent particle in one-dimensional box along y-axis. This will represent particle in one-dimensional box along y-axis. So we can use the similar result, that is y, that will be equal to, now this is 2 by b whole to the power half sine, let me write it as ny pi y by b, and ey equal to ny square h square by 8mb square. So again here ny equal to 1, 2, 3, etc. Okay. Similarly, if we take the equation containing z, we will get another equation. Okay, and that equation will be like this. Minus h bar square by 2m z double dash z by z equal to Ez, which is a constant, and so z again particle in one-dimensional box, so this will be equal to 2 by c. Now this is c whole to the power half sine nz pi z by c, and Ez, that will be equal to nz square h square 8mc square. Okay, so we are getting xx, we are getting xx, we are getting yy, we are getting zz. So what will be the value of psi then? Because we have assumed psi equal to this into this. So from 3, so from 3 psi will be equal to 2 by a, let me write the constants, 2 by b, 2 by c whole to the power half sine nx pi x by a sine ny pi y by b sine nz pi z by c. So we get this, or we may write it like this: 8 by a b c whole to the power half sine nx pi x by a sine ny phi y by b and sine nz pi z by c. Okay, so we are getting the wave function. Okay, then what is the total energy? Total energy will be equal to ex plus ey plus ez. Total energy equal to this. So this will be equal to I can write it like this: h square by 8m nx square by a square plus n y square by b square and n z square by c square. So we are getting the value of energy. So you see, now from by studying the problem, what we learn actually. So we have learned how to solve the Schrödinger equation if it contains more than one variable. Okay, Schrödinger equation যদি এটাতকে বেছি ভেৰিয়েবল থাকে আমি কেনেকৈ সলভ কৰিব লাগে, কেনেকৈ সলভ কৰিব লাগিব? ইকুৱেশ্যনটোক আমি কিছুমান সৰু সৰু ইকুৱেশ্যনত ডিভাইড কৰিম। ওকে, ডিভাইড কৰিম, তাৰপিছত আমি সেই যে সৰু ইকুৱেশ্যন পাম প্ৰতিটো ইকুৱেশ্যনক সলভ কৰিম। That is how we solve the Schrödinger equation when it contains more than one variable. So we get psi, we get energy. Now using these results, we can explain degeneracy. We can explain what we mean by degeneracy. Okay. Now for that, let us assume that A equal to B equal to C. That means the box is a cube. Cube means it is symmetrical. Okay, symmetrical. Okay, so that is it is a cube. Cube means it is more symmetrical. I write symmetrical. Okay. Now in that case psi will be equal to 2 by a whole to the power 3 by 2 sine nx pi x by a sine ny phi y by, I can write a, I can write b because you cannot simplify further. Okay, you may write a here, no problem. Nz pi z by c, you can write a here, no problem. And energy will be equal to h square by 8m a square nx square plus ny square plus nz square. Okay, we get this. Now say if nx equal to ny equal to nz equal to 1, then let me write it like this: nx1 ny1 nz1. Let me write it like this: nx ny nz, and that will be equal to 1 1 1, so it will be 3 h square by 8 m a square. It will be this. And the corresponding wave function, let me write it like this: corresponding wave function will be psi 1 1 1 nx, ny, nz, psi 1, 1, 1. That will be equal to 2 by a whole to the power 3 by 2 sine pi x by a sine pi y by b sine pi z by c. Pi z by c. Now if nx equal to 2 but ny nz equal to 1, then energy 2 1 1, that will be equal to 4 1 1 6 6 into h square by 8 m a square. Okay, a square. Then wave function psi 2 1 1, that will be equal to 2 by a whole to the power 3 by 2 sine 2 pi x by a sine pi y by b sine pi z by c. Okay, so energy is this, wave function is this. Now if n y equal to 2, n x equal to n z equal to 1, then what we get? Energy 1 to 1 equal to same energy 8 m a square. Now wave function 1 to 1, 1 to 1, that will be equal to 2 by a 3 by 2 sine pi x by a sine 2 pi x by y, sorry b, y by b, is y by b, and sine pi z by c. Okay, similarly if n z equal to 2, nx ny equal to 1, then energy will be equal to 1 1 2, same energy 6 h square by 8 m a square, and wave functions 1 1 2, that will be equal to 2 by a 3 by 2 sine pi x by a sine pi y by b sine 2 pi z by c. Okay, now you see here so when n 1, we have one energy value and we have one value of psi, one energy value, and one value of psi means one state. Psi represents state. This energy value, there is only one state, psi 1 1. Okay, only one says psi 1 1 1. Now here you see this energy value, same energy value, 2 1 1, 1 2 1, 1 1 2, same energy value, and we have three states, one state, two state, three states. Now do they represent the same state? No, because it is twice along x, it is twice along y, it is twice along z. So these three wave functions, that means three different states. These three wave functions represent three different states. Why? Twice along x, twice along y, twice along z, three different states. So one energy value and three different states, three different wave functions. Let me show it like this. So say energy is increasing, okay? Energy is increasing. We have this energy value E111. We have this energy value. There is only one state, psi 111. But this energy value, okay, this is 6h square 8m a square, this energy value. There are three states. One state psi 211, another state psi 121, another state psi 112. Okay, there are three different states. One energy value, one state. One energy value, three states. Three wave functions means three states. So we say that this energy level is degenerate. Why? Because this energy level consists of more than one states. Okay. So what is degeneracy? If one energy level consists of more than one state, then that energy level is said to be degenerate. If one energy level consists of more than one state, then that particular energy level is said to be degenerate. So with the help of particle in three-dimensional box, we can explain what we mean by degeneracy. Okay, one energy level having more than one state, then that energy level is said to be degenerate. Okay, so let us stop here today. Next we will discuss something else. Okay, thank you.